Hello, everyone. I'm privileged to talk to you about Apex and introduce Apex to you today. And thank you for your interest in coming and attending this conference and making this conference possible. So earlier in his keynote, Mr. Ghosh talked about the different kinds of streaming applications that are possible and the new interesting kinds of problems that people are trying to solve. And you saw that all those problems were quite different from each other, right? The only common component was data is streaming at a fast pace. And he also mentioned towards, when he was answering a question, that companies are realizing that they need to standardize on a platform that handles all the nitty-gritty and the complications of big data processing and distributed computing so that they can concentrate on their business logic and what they're trying to do, right? And then later on, Amol, in his talk, talked about all the different things an application needs to do from an operational perspective to be usable in production, right? And you saw there was a big list, right? So when we started building Apex, our goal was that. Our goal was to basically create something that can help you solve different kinds of problems and let you concentrate on your application rather than worrying about all the underlying issues about the infrastructure. So with that, I'll start. I'll go deeper into Apex and stream processing. So as many of you probably already know or already seeing, that the world is moving from a batch-based processing to a real-time stream-based processing. So before, what you used to do is when data comes in, you would store it first and process it later. Now people are trying to invert this. So you're trying to process the data as it's being generated and as you're receiving it, right? And the kind of processing you're doing is getting more and more sophisticated. And then you can store the results later. So to be able to do this and to be able to handle the large amount of data at the speed it's coming in, you need to divide and conquer. Right? So you need to run your processing logic on multiple computers. You need to have access to large amounts of memory, whether it's RAM or storage. And you need to be able to have a platform that lets you do that so that you're not doing computer science, right? You're not basically inventing low-level technologies. So what's a stream, right? So the stream is actually an unbounded data. So think about a tweet stream, right? If you, for example, subscribe to, if you use the Twitter API and subscribe to tweets, you're getting tweets continuously, 24 hours a day, never stops, right? So you have this unbounded data that's coming in and you're processing it. So there's no notion of start and end, but then there's some different things that you can define. So you can define temporal windows for your processing. These could be fixed windows, or these could be windows based on certain timestamps in your data, and you can calculate certain aggregates or other things on these windows, and then you can store those results somewhere or send it out for further processing, right? And whatever you're doing needs to be stateful. Let's say you have been processing data for a day, and there is some problem, some machine, one of your machines in your cluster goes down. You cannot start from the beginning, right? You need to be able to quickly recover from wherever you failed and continue, because new data is coming in all the time. And you need to have the capability to be able to read data from different kinds of sources, because not everybody uses the same kinds of transport, the same kinds of protocols. You need to be able to parse and receive different kinds of data, to your question earlier, sir. And you need to be able to also store things in different places and do different kinds of processing, right? Okay. So what's Apex, right? So Apex is actually a platform that runs on Hadoop. It's a stream processing platform. As data is streaming in, you can perform whatever kinds of computations you want. It's totally in memory. It's distributed. It has a very simple programming model. Basically, most of the time you're writing your own Java code, whatever Java code you want to do. You basically take a big problem that you're trying to solve, you break it into smaller chunks, and each chunk you code it up independently, and these chunks are then sent over, are basically deployed over the Hadoop cluster, and they're running. And Apex takes care of moving the data between them as well. So this is like your pipelining that happens within us. For example, you may have learned in when you're learning about CPU architectures, right? There's pipelining that happens there. So this is similar to that, but happens at a higher level, at a process level. And it's scalable. So every piece of the logic you write can actually run in multiple different processes across your cluster so that you can handle higher data speeds and higher amounts of data that are coming in. It's fault tolerant, so even if there are servers in your cluster go down, you don't lose any data. There is no, the results are always correct. And we can even do exactly one. So if you're storing data to an output store, you don't miss any data. You don't get any duplicates. And Apex also comes with a big library of business logic that's ready to use. So if you're trying to read from common streaming sources like Kafka, or even from files, or from databases, or trying to parse JSON or CSVs, all those things are already available for you. You don't have to write them from scratch. And DataTorrent provides a bunch of operability tools that basically satisfy the things that Amol was talking about earlier, that help people who are actually maintaining, developing, managing these big data applications. That makes their life very easy. So this is the how the technology stack looks like. So at the bottom is Hadoop. You can have any Hadoop distribution. You could be running on a physical infrastructure or on cloud or on virtual machines. Doesn't matter. And Apex basically runs on top, and basically your application runs on top of Apex engine. And then there's different ways to create your applications, and I'll briefly touch upon that later. We provide an operator library that you can use to jumpstart your application. And we also have application templates that we provide, so that you are not, suppose you have a common ETL pattern, you can basically start from that template, and you'll be probably already 40 to 50% there, and you can plug in your custom logic in between. And then we have a bunch of UI tools that DataTorrent provides for monitoring and debugging and real-time visualization of the data as well as metrics. So this is the application development model. The first thing you do is you take your big problem, you break it into smaller pieces, you code each of them up. Each of them is called an operator. You can write your own operators, or you can use the one from the library, and then you connect them up as a graph. And as data is coming in into an operator, it's basically delivered immediately to the operator. Operator can do some processing and send something out for the next operator. And while that result is being sent to the next operator, it is ready to process a new piece of data, right? So this is standard pipelining. So this is how the architecture looks when everything is running on your Hadoop cluster. So you see some MapReduce blocks there. That is just to show you that we can coexist with any other Hadoop technologies that you have. We're not using them, like we're not using MapReduce or anything like that, but we won't interfere with them. So let's say you have an application with 6 operators. Those are those green boxes. And you can see them that they are deployed across different nodes in your Hadoop cluster. Here there are 4 nodes. Those four boxes are 4 nodes. And each of those green boxes is basically a portion of your business logic that's running. And these can be located in different ways. So if you can see, 1 and 2 are actually different processes on different machines, whereas 4 and 6 are actually threads within the same process. And there is another box that you see called STRAM, which is a management process that's running and making sure everything is working fine. And if there's any failures or anything like that, it basically recovers those pieces of your application. And then there are some other tools that we have for launching applications and managing and monitoring that I talked to you about that you have at the top of the picture. So this is how it will look when an Apex application that you built runs on a Hadoop cluster. So let's look at a sample application. So let's say you were given a problem that you have a bunch of streaming data coming in from message queue like Kafka, and you need to parse it, you need to do some filtering, maybe you're trying to do some word count, and storing the output to a database, right? So it's very easy. I mean, a problem like this, you can almost see that there are 5 different operators. The first one is going to read from Kafka, the next one's parsing, and so on and so forth, right? And here, if you are doing something like this, I mean, you could build this up in 10 minutes on Apex, because 90% of the core the operators are already available in our library. And let's say you're writing your own word code filtering or something like that. You just need to write one operator, and you basically wire them up. And once you do that, you can quickly deploy the application, and you can basically test it and see how it's going. So as I mentioned, that we have a library of operators that are ready to use for you. And this shows you that it touches basically almost all the different types of technologies that are used, right? From databases to message queues to different even analytics as well. And I promise you there won't be many slides with code. This is one of them. So let's say you are writing an operator yourself. So I think anybody who's just learning Java can also write this. So you can see that you write a class, you extend some other class, and you define an input and an output port. Input port is how you receive data. And when you receive data, this process method gets called, and you can do whatever you want in the process method. You can put your own any code. And in this case, I'm basically checking whether that string is an article. If it's an article, I'm going to drop it. If it's not an article, I'm going to let it through. The way I'm going to let it through is I'm going to emit it on an output port. And this will go to the next operator automatically, and Apex will take care of that, right? So you can imagine this is, so the programming model is very simple. You just have input and output ports. Everything else can be whatever you want, right? And there are different ways to create your application. So there's a compositional way, which is what this example below is. You basically take all your operators, you instantiate them, and connect them up like a graph. But there are other ways as well, which Chinmay would be covering later on. So do attend that talk. So there's high level with windowing, high level API, Beam, Stream SQL, JSON. So there are different ways for you to create your application. And let me go a little bit into the scaling options, right? So let's say you have created an application with 4 operators, right? In this case, let's say 0, 1, 2, and 3. Now, you can choose to run them all of them as single processes, and then you can process a certain amount of data. Maybe you can process 10,000 events per second, right? But what if you're now getting 30,000 events per second, right? How do you process that? So maybe the operator 0, which is actually just fetching data from a source, can handle 30,000 events per second. But operator 1 may actually be doing some parsing, so it's doing more complicated processing, and it cannot handle 30,000 events in one process. I mean, it cannot handle at that speed, right? So what you do, you basically divide and conquer. So we can partition this so that you actually now have, let's say, 3 operators that's running the same logic, and each of them is getting a subset of the data, right? And then their results will get unified and go to the next stage. And you can do different kinds of shuffles before, as you transmit data. You can do this. You can do parallel partition where there's no shuffle. Every stage has the same number of partitions, and data is flowing directly from one stage to the next stage. Or you can have shuffle if you have different number of partitions in different stages. And the last case is if you actually have a lot of partitions and you're trying to take the results and then aggregate them together. And there's so much data that you cannot just bring it into one process, then we can do cascading. So we can first bring it to a set of processes. They compute the intermediate aggregates, and their results will go to the next stage, and it kind of will start reducing down. And the feature that's unique is to Apex's dynamic scaling. So you don't need to define these number of partitions statically when you launch your application, but it can respond to the speed at which data is coming in, and it can also actually respond to any condition you want. So we actually made this an API, so you can actually write your own scaler, and let's say you expect at 10 o'clock in the morning you're going to get a huge amount of data. At 9:45 you can trigger the scale. The scaler can say, I want to just scale from 4 to 8 partitions, right? And then there's an interesting side effect of this. So our Kafka operator has its own custom scaler. What it does is you just specify the Kafka topic, and as you know, Kafka is a distributed message queue. So it can query Kafka, find out how many partitions are there on the Kafka side, create as many number of partitions on the Apex side, and they all will parallelly read from all the different Kafka partitions. So they can bring data at the highest throughput possible into the processing engine. So with all this, the simple word count example that I showed you at runtime might look something like this. So the inputs, basically, in this case, I had a Kafka topic with 2 partitions. So the Kafka operator got partitioned 2-way. And for parser, filter, and counter, I specified 4 partitions each. So you can see there are 4 parallel streams. And I said that I want parallel partitioning, so they're all parallel. And eventually, the final results got aggregated and sent to output. So this is the scaling aspect. So the next important aspect is the fault tolerance. So if you have a distributed application like this, and it's running across the cluster, and it's basically continuously running all the time, at some point you'll have some hardware failures or something in your cluster, and things go down, at which point the application needs to be able to recover. So Apex has that capability. So the state of every operator is being automatically checkpointed. So if you have any aggregates or counts, they're all preserved, and when recovery happens, it happens in an incremental fashion. Only the operators that fail are recovered, and they're recovered with the right state, and the corresponding data is, a small amount of data is recomputed, but your results are still correct. So the reason one of the quick pieces we are able to do this is because we have an internal buffering mechanism. That way we can recover incrementally, and we don't have to reset the entire application. So I'm going to go a little bit faster because of the time constraint. So end-to-end exactly once, it's important when you're trying to write to an external store. So what is end-to-end exactly once is, in case there is a failure and there is a recovery and there's a little bit of recomputation that happens, you still don't want to have duplicates written in the output store. So if you're basically using our operators that are in a library, like a database operator or a Kafka output operator or a file output operator, they basically ensure that even in case of a failure event, there's no duplicates in the output files or output store. And here's brief screenshots of our tools. This is our monitoring tool that shows you different aspects of a runtime application with all the deep metrics. And there are talks later on in the day where people will go into detail on these things. And here's a real-time dashboard. If you have an application that's actually outputting real-time data, and you want to visualize it even before it hits some store, you can do that with these widgets. They are very responsive, and they're built to stream data in at a high speed. We also have an application designer. So if you have a bunch of operators that you have already written, and you want to give it to a data scientist who doesn't know how to code, and he wants to build his applications, he can use this canvas to connect them up. And as mentioned earlier, we have an app hub with a bunch of ready-to-use app templates that you can use. You can start as your platform, and we are adding app templates all the time. So do check it out. Just want to end with a couple of customer use cases. GE. So GE has a industrial IoT platform called Predix, and they're basically using Apex underneath for their ingestion and streaming analytics. And of course, for machine learning, they use Spark, I think. So basically, they handle the data. Their data volumes are in the order of millions to tens of millions of events per second. So that's the speed at which data is coming in. CapitalOne. So they're basically using Apex for fraud detection. So when you swipe your card, in the loop, they want to detect if it's a fraudulent transaction or not, and return the response to that point of sale terminal, right? So the requirement was to do this in 40 milliseconds. They were able to achieve it in 2 milliseconds. So they were able to achieve 99.999% of the transactions. They were able to do the fraud detection processing in 2 milliseconds. So you can see the speed at which we can process data. And here's slides which have basically links to the talks from G and CapitalOne, which they have themselves given, and you can check it out. So and then I have some links for the resources on Apex, and I'll take any questions.
You have told us what are the stuff that you do well. What are the stuff that you don't do well? Because there are other platforms like IBM's Big Insight and those others. just share with us what do you think are the limitations of your platform?
Yeah, so I think one of the things someone mentioned is machine learning. So we are not kind of designed for that. Though we are starting to, there's some basic capability there, but I wouldn't claim we have machine learning. SQL is another area which is new to us, but we're starting to support some basic stream SQL there. And also I think so batch is one good area. Actually, we have customers who migrated their batch to do basically batch on stream. But if you go to some of the mature batch platforms, they have all kinds of scheduling and all kinds of things which we yet to have. But I would say those are the three things.
Hi.
Hi.
So this partitioning you mentioned, right? So
Yes.
how does it work in case of join? So let's say, take an example, like you have an order data,
Mm-hmm.
which has multiple keys like item key, location key,
Mm-hmm.
and at different point in time in the ETL pipeline, I need to join with different keys.
Yeah.
So how does Apex handle that kind of scenario?
Yeah, so we give the ability for the application developer to choose the keys at different stage on how they want to partition. So they can partition based on one key or a combination of keys, and it can be different at different stages of the pipeline.
So does it duplicate the data in memory or?
No, it doesn't duplicate the data in memory.
Yes, thanks.